Welcome back to another HVAC Time podcast. So sitting here with Kirk today, and we're going to talk about the current situation with VRFs and VRV, if you want to talk Daikin, and what we see as their future, what we see the industry doing. There's a lot of chat and a lot of conversations, and I also see some opinions online I find very interesting. So we're going to dive into that today. Now, if you're watching the video podcast, you notice we're in a little bit of a weird scenario. So
Still in Massachusetts.
you check out the last podcast that was covering our travel and our event here, and while we're in Massachusetts to begin with, and it's about VRFs. So go look at that. Otherwise, let's get into VRFs. So if you don't know, if you're not familiar, VRF is it's a variable refrigerant volume technology, and it's extremely efficient when it's done correctly. And it's a way of taking, really consolidating a lot of indoor space units and being able to bring that to a central set of outdoors.
Yeah, it can be done, a couple of different ways in terms of thinking about how it operates. Is you can turn a lot of different split systems or mini splits into one consolidated system, or it can be thought of in a way of decentralizing a central plant in a way to save energy that way.
Yeah.
So that's the two ways I think about it. What's your purpose there?
Yeah, exactly. Its ability to match specific loads in the space is quite incredible for what it is. I mean, the way it can ramp down and just barely cruise to keep one or two indoors going.
Mm-hmm.
Or in a heat recovery scenario, you're able to heat this space while cooling this space at the exact same time, and it's perfectly fine.
Barely makes it to the outdoor unit at that point.
It's quite remarkable what it can do.
Mm-hmm.
But there's a lot of drawbacks.
You got to understand it. You got to know what you're doing. You got to know how to install it. You got to know how to program it. You got to know how to operate it. There's some hurdles. It's definitely not just a plug and play. That's for sure.
I want to say thank you to today's video sponsor, which is CSG, Compressor Solutions Group, based out of Houston, Texas. They've also got a shop in DFW serving the Texas area, and they also can provide you compressor service nationally. They're a great group of guys. They've done a really good job with just getting their information out there. They try to really invest into training in this industry and just supporting the contractors. Reach out to Jake with any questions you have. He'll be able to take care of you, be able to help you out. They do full service and rebuilds on screw compressors and semi-hermetic recips. They've been a great friend of the channel. They've been a great friend of mine. I look forward to working with them for a long time to come. Well, what have you seen on your side as to probably the most common issues you've run across, just in general?
In terms of service, because the most common issues I see are just and you can cut this if you need to, but a lack of understanding on how to troubleshoot it. Whether it's just a board that failed and no one can tell you exactly what portion failed. There's no things put in place that are giveaways like fuses that blew. So you end up having to replace multiple components just to be safe. But also it comes down to other common issues I've seen is just knowing how it operates. Someone tells you that it's a ability to heat and cool at the same time and they sold you a heat pump system. It's not true. Your understanding of the situation is not there. And that was a true service call I had. They told me it could do both. I'm like, well, they didn't tell you that. Yeah. Wow. It's just a heat pump.
I haven't ran into that one. They said it had heat recovery capability, but it didn't. I have ran into it where they wanted it to do that. So I was working a medical clinic, and that ended up being the problem. They had it set up for a master thermostat, and what would happen, that master thermostat was in an interior space, and that interior space would end up getting cold, and it would end up shutting the system down. But all the exteriors would run hot. So I ended up reprogramming that one to run on a voting-based system, and that made a big improvement. But that was one of the things that somebody there had heard that they could do both in a heat recovery aspect. But in this particular case, yeah, it was just a basic heat pump. It didn't have any kind of recovery, or it didn't have any branch selectors or anything tied into it. So, Yeah, I think my biggest things, I agree. A lot of it comes down to lack of understanding of the system, and coming in behind a lot of people who lack that understanding. But in addition to that, I think my number one that I always deal with the most comes back to commissioning.
Yeah.
And so many systems have bad commissioning. They weren't done correctly on install. They weren't wired correctly. They weren't piped correctly. They weren't charged correctly, and then they weren't programmed correctly.
Yeah, that's been my. I guess like, if we're, adding on to my statement is correctly programmed systems that I actually go to service or PM has been the bane of my existence on these things, and it's been a learning curve.
Yeah, you've
Because
actually.
I looked in the mirror and it's only me that touched it, so it went down. I'm the one that broke it, and in reality, someone set a trap, and I fell right in.
Yeah.
I've dropped them off of, not physically dropped them off buildings, but I've dropped them off of their automation systems to where the unit just doesn't exist anymore. And I did not have the technical know-how to get me back to where we started. And that was a tough conversation for a few customers.
Well, that's exactly one of my scenarios. This happened a few years back, but we were troubleshooting I think it was one of the early versions of the Multi-V 5 series, and it had a very poor install to begin with. The piping was not good, but the wiring was not done correctly at all. And while we were trying to do some troubleshooting at the outdoors, one of the things we had to do was move some of the comm wires around in the process. That wiped the entire network, including at the AC Smart. And thankfully...
Was this a building I worked on with you?
We didn't work on this one together, but
Did you start this one? Did I start this one?
I don't remember.
Was this, I feel like this is the one I started. But, okay, I have a question. Are there two separate banks on different sides of the building with the penthouse in the middle that you have to go downstairs and back up?
Yes.
Yep. Okay. Yep. I know what building you're talking about. Absolutely know what building you're talking about.
Yeah, because it has some Aeons up there too.
Yep. 3 of them.
That sounds right.
2 on one side. Yeah. Okay.
Yeah, and the AC Smarts triggered the start stops on them.
Uh-huh. Yeah. Yep. Okay. Yeah. We're following.
So it was that building, and it wiped the whole network. Thankfully, they had a file on site that showed all the addresses and what everything was supposed to be. So we were able to go. Well, I had to go back through. It took me an entire day to reallocate all the different systems to where they belonged. It was a utter nightmare. But that's one of the things, to me. It comes back to if I remember correctly, they didn't use shielded wire. So they used the wrong wire on the system, and then they didn't daisy chain it properly. And that was one of the very first things I determined whenever I got on site. Looking at it, it's just, this wiring is not okay. Like, who did this?
Yeah, I think with any of these variable refrigerant, variable whatever you want to call it, VRV, VRF systems, the first thing you need to do, whereas if you're going to troubleshoot a pump or a split system or mini split, is paying attention to the nuances of an install is not as important. It helps, if you're going to diagnose a pump vibration, it's not aligned. Well, okay, that's fair, but you can get away with certain things on those systems and hide it very well. Maybe not mounting things properly or whatnot. But when it comes down to the nuances of an install on a VRV, VRF system, that's almost, I've gotten to the point where that's the first thing you check now. Because, like you said, the experience with the commissioning process and all that is the number one issue. So you start there. That's the first thing you start paying attention to rather than just focusing on a particular portion of the unit that's not working. So looking at the big picture immediately rather than just the small things.
Well, and one of the things, so this, I don't know firsthand, but talking to some of our folks from Europe, this has been the standard in Europe for a number of years, up to at least 10 years that I'm aware of. And we see that, I think here in North America, we're roughly about 10 years behind a lot of what the European HVAC market has done.
So before you get on your tangent, now why so is Europe so far ahead of us on this mainly because it's a lot harder to add, say, chilled water systems to something like that, and because it's the footprint of a VRV VRF is smaller? Is that
I think that's part of it, maybe, or they need to add capacity, and it's really hard to do that with a traditional system.
because I mean they've got a lot of very ancient buildings that they're maybe renovating, and you can't just add a maybe they can't support an air cooled chiller on the roof, or they don't have room to add a full on central plant somewhere.
But to add to that, I think it's probably more than just availability. If I had to, now I'm just assuming here, but I would also venture to say that their regulations, they have way stricter energy regulations that I understand at least uh, than we do.
Yeah, and you can unload pretty far down.
Right. Well, so these systems meet those energy requirements in a way that uh, that we don't have to. You know, we're starting to have to. You know, we're seeing these things come our way. Um, just like talking to the guy here in in Massachusetts, he was saying that several major cities here in Boston, starting next year, no fossil fuel systems are allowed to be installed from that point going forward. It has to be electric in some way, whether it be heat pump or just the whole electrification thing taking root and getting rid of all fossil fuel.
So that just what boilers? I mean,
Yeah.
I'm just trying, like you said that, and I was trying to kind of catch on without interrupting the conversation. So, okay,
Yeah. Yeah, their whole boiler market's shot.
that's very interesting.
They just completely cater an industry.
Right? Yeah. I mean, what happens if Chicago or New York says that? You know, they've got literal steam vents going underground, steam pipes going underground to different buildings.
Well, at that point, I mean, granted, sure, the pre-existing could stay.
Right, but I mean, again, that market's not exactly small.
I agree. I agree. No, it's a good question. It's a very good question.
You know, I mean, I see it that being that way in the future. We're already going that way with cars. I don't expect, you know. Now that being said, too, is you can generate steam with electricity, so there are ways to do that. But
Well, and I also wonder because we see there's different regulations for the scale. So we see that in Texas, where the residential, like commercial side of things, will have a different like the amount of loss. This is actually an EPA regulation. The amount of loss you're allowed per year before it's considered condemnable by the EPA. You know, it's an unacceptable amount of loss, and we as the technician are to some degree held accountable to allowing that system to be charged and run if it exceeds that value. Whereas on a commercial system, if it's I forget the tonnage, but if it's over a certain amount of tons, the EPA has a higher value. You can lose more total volume than you can on a smaller system.
I mean, yeah, I know that. I don't remember the numbers either. But
Yeah, so I wonder if maybe there's some aspect to that of maybe some of these larger, more industrial size systems that are much more heavily engineered.
well, that too, and I guess is when you pull the individual consumer out of having to maintain efficiency, you can push that to a larger plant, which is easier to focus on. You know, the regulations. You're not having to travel all around to make sure everybody's up to code. You can just force that code to be in one spot and easier to regulate there.
And that's a very valid point. That would take, while it may add strain to the electrical side, it takes a lot of strain off of some of the other, especially the natural resources that they want to, you know, they want to reduce the total capacity of it to begin with. Yeah, no, that makes a lot of sense. Well, so something getting back to the Europe piece, something that I've seen some feedback from our European fellows, and they're starting to remove some of these things. And according to them, you know, that HVAC, that VRF's technology has been so difficult for them that a lot of facilities are finding ways of switching back away from it somehow, which I find interesting. And I've also started to see that same kind of conversation and trend happening here in North America, where And specifically, there's people in the United States where I see comments from that. Oh well, this is going to go. This is dead in the market. It's going to go away. It's only got a number of years left. Or we're ripping out these systems and we're putting back in chill water. And I really question that because I think that might be true in some small scales.
I don't know of any building that we've worked on where they've ripped out their system.
I agree, and that's part of my point where I'm going with it is I don't think that is true. Maybe it is for Europe. I can't speak for Europe, but for those who I see on the American front, um, this is our future for a number of years. Like, and we're just now really seeing this steamroll into the market in ways that we haven't seen before. And with regulations like what Massachusetts is doing, it's only going to embolden these systems taking over. And so I would encourage you to really dive in and learn these things because this is the future of the HVAC industry for us here.
With that being said, I agree with you. It is the future because you don't turn back technology, right? Unless somebody comes up with a much more efficient way to run a chilled water system and unload it to the point where you can run 9 amps and keep your units cold. I mean, that's literally what a VRF can do. You can have 89 units and keep somewhere perfectly comfortable and run it for less than 9 amps. You can't do that with a chilled water system. It's impossible. You got to run a pump. You got to run an air handler. You got to run all of that and a chiller on top of that. And I guarantee you're not running a chiller for under 9 amps itself. But that being said, if it's the future, then I know that the companies that produce these units, whether it be LG, Daikin, Trane, what have you, they need to make it friendlier for the techs. Because if it is the future, if it is going to be so popular, the terminology, the access to information, the confusing way some of it's stated in those manuals needs to be clearer because not everyone that can service an HVAC unit has the ability to walk up to this thing and understand it if the customer doesn't know what they have.
And that's I see the point. It's a valid one, but to some degree, I can see from their perspective, it's a hard line to toe because we ourselves need to educate ourselves to the point of being able to rise up to match the equipment, but the equipment we're talking about is inherently very advanced.
And I understand that, but the customer doesn't know how advanced their equipment is all the time.
Yeah, well, so maybe better PR then.
Something to where whether it's more friendly. I mean, granted, these companies do a great job of putting apps out that help you find their error codes and even flow charts to troubleshoot it. That's fantastic. But again, the customer doesn't know to request a tech that has experience working on these systems because you can't always just send a new tech out there because a random person called in and said my AC isn't cooling and he walks up and he sees one small air handler not running and he goes up to the roof and he finds out it's connected to 25 other units. That's something that it's not. He may have the basic understandings of HVAC, but if it's going to be something that's this popular, it needs to be friendlier in a way to troubleshoot. That's where
it's true. Yeah, well, I guess that's part of where I struggle is I want it to be easier. I do. But knowing what all it contains. You've got a very robust communication automation networking system functioning inside of this thing. I mean, and you know, HVAC techs, we don't think of ourselves in terms of being automation guys.
Not usually.
But right, but in reality, especially with systems like these, we're bridging that gap more than we realize. And so if you're not used to dealing with communication protocols and things like Modbus, things like BACnet, or in the RS-485, if you don't know what that is, now's a really good time to start learning it, because this is it. And even outside of just VRF, let's take that a step further. Let's look at the Train Odyssey system, with their Symbio controllers.
Okay.
They're a fully communicating split system, and this is what Train's putting out there especially on their light tonnage side, and they're going to scale this up. That's what Train has always done with this thing. So this is just the beginning stages of it. We're just starting to see the last few years where these things are getting put in. You have to program the thing with an app on your phone, and the thermostat goes to the outdoor unit, and then the outdoor unit has multiple COM buses that run to the indoor unit to tell it what it wants it to do, how to work the heat, what to do with the fan, and they're putting VFDs in those things now even. So those lines of technology are beginning to blur in ways that they didn't have to for a long time. So getting to the accessibility.
Well, and I guess that, when you say that, is like, that's not, I'm not union, I'm not, I don't go to class every, whatever, but, in the trade schools, like, this was not, you weren't, when you think HVAC in the trade school, like, you weren't prepared for, networking problems and stuff like that these units bring. So I guess that's part of the learning curve that goes with that. And so I think that's where a lot of guys, myself included, when I first started working on these things, is you throw your arms up in the air like, dude, that's so foreign to me, I don't understand. And I guess that might be where my statement comes really to a wall there.
Well, that is a good point of how would a trade school, especially with a professor who's never seen this himself a day in his life, how would a trade school properly bridge the gap while still covering because in my opinion, that's what a trade school really should be. They should be focused on, here is the fundamental basics, here's the science, here's the math, here's how it all works. And you're going to learn how all this works and put some hands onto it. You're going to make all this happen. And then we're going to come out the other side of this, and you're going to go work for somebody who can teach you the rest out there. You're going to live this life. You're going to get to experience it. So, how would a trade school?
Well, I think a basic class on, if my trade school, right as I was leaving, had a master slave unit set up, or it was being set up as we left. So if you were going to bring that particular system into your trade school, into your lab, then there has to be an expectation of how to work on it. So yes, you understand how electricity works, but do you understand how data is communicated? What's the purpose of a shielded wire? Why do you need that? I didn't know that when I was in school, and if that's something I'm going to be working on every day, and it's going to be so popular, why are we doing that? And if that's that's part of the basics at that point. Yeah. It does become part of your basics.
Well, teach it along. I guess that's absolutely valid. Teach it right along beside thermostat wiring. Mm-hmm. As you're learning thermostat wiring, teach about communication wiring. Mm-hmm.
That's all a thermostat is communication. So.
Right, yeah, it's just different types. Because, some like Daikin don't use shielded. They're just an 18.2 by itself. Whereas LG, and I think Mitsubishi as well, require 18.2 shielded. And Samsung does not. Samsung and Daikin are non-shielded.
Samsung leaves it, if I remember correctly, it leaves it up to interpretation.
Does it? Okay, I'd have to go back and...
yeah, I'd have to go back and look, but job site I was on, there was a couple of different ways they were wired.
I don't think we ran shielded, or if we did, I don't think the intention was to run shielded.
Some of them were, yes.
Well, and even shielded, that's a good one. This is one that I recently started to learn about myself. What happened, or what's the detriment if you put in a shielded where it's not needed? So let's see if I can even explain it off memory. But essentially, it can create the shielding can create this I think they call it a ground loop, where
I'm already understanding how that's going to work.
Yeah, yeah, and so
It creates its own interference.
exactly. It's almost like running it next to power lines.
Right. Okay. Yeah.
And it just is, and it scrambles the whole communication bus. And so that's why Daikin doesn't want to use that, because the way they send the signal back and forth and they filter the data, that ground loop just scrambles it. Whereas LG and Mitsubishi, on the other hand, they do it in a totally different way. So yeah, so accessibility. I understand the complaint. I struggle with, at what point is it they're not going far enough? And I'm not advocating for the manufacturer here, right?
No, and I understand where you're going to go with this.
It's just,
At what point is it the manufacturer's responsibility to give you information versus what point is it the tech's responsibility to go and understand what he's actually going to go work on?
right, because let's take this into the chiller side. Maybe there is people. I've not been this way, and I know that most that I surround myself with are not this way. So when you think of the chiller side, you don't think of it of, oh well, York and Train don't do enough to engage with the technicians and the customer to show their equipment and get people involved and do all this stuff, right? And their classes are far more expensive than getting an LG or a Daikin VRF training. So, we don't take that mentality to chiller side.
But I also think there's two things that I'd say with that is the chiller side is a much more the community for chillers is a little more vast. Right? They've been around longer. You've got the techs that have gone to all the trainings for it, and the information is there. You've got strong mentors who have been working on these things for 30, 40 years, and they understand everything about it because they've encountered everything under the sun. So the network is there to ask these people the questions. Maybe I may ask you, I may ask some of the other guys at Air Performance for these for the knowledge I need if I can't find it in a manual, or understanding how a process works. And so, but to also go with that is, I think the maturity of the people who have been working on these things for 30, 40 years is different than the maturity of the people who are just getting into the field and they're starting to work on VRV, VRF systems. Whereas the guys who have been in the field for that long working on chillers, that's all they're working on anymore. And so, I actually kind of lost my train of thought on where I was going with the maturity aspect of it, but I feel like it does play a factor in that.
But with that, I would venture to say that most of them have retired at this point.
Right, but you may still have that guy that you worked with 10 years ago and he encountered, there's a guy that we work with and he calls people from all over all the time. I haven't talked to him in 15 years and he calls them up for tech support.
Yeah, that's valid. Well, okay, but so using them as an example, fine. But you as a current chiller apprentice yourself and really getting heavy into the chiller side, learning that piece of it, and working yourself into being a chiller technician, would you have that same expectation of York to do what you're claiming you might want LG or Daikin to do now? And why is it different?
I feel like they do that though, with all of their revisions to manuals and stuff, and like blinking on the name of it, but they've got that entire database where you can go find any information, and it's clearly, labeled, what code you need and what all that is to find the manual you were exactly looking for. And they've got the revision date. They've got all of that ready for you when you need it. So I do feel like the manuals are, like, granted, we had this conversation earlier about how hard it is to actually find the particular portion of what you're looking for, where it says, hey, go see this, and you're in the manual you thought you were in, you've been reading it for 45 minutes, and it's reality you're supposed to look in a completely different part of the library. But I feel like the information is there for a lot of that.
And you don't feel like it's there for the VRF? Not
yet. And I do think that's got to do with how new they are.
So what information do you think is not there? Like, if you had to give an example. I know it's kind of on the spot, but...
I think some of the terminology is kind of hard to find sometimes. There's a few things in there, like I think I had to confirm what trace meant. earlier today. Like, why don't you just call it, actual, something like that. Just like some little things, Again, being on the spot, I'm sure I've got more. I'll find them later, as most of our conversations go. But there's little things that I think could be made friendly. And I know some of the translations are not always initially printed in English, and some of the conversions from translations are a little off sometimes. I know in particular the Samsung one has an entire fantastic program to work on their system, but there's one section where you click on and everything's still in Chinese or whatever, Japanese, whatever it is, but or Korean. Samsung's Korean.
Oh, you are right. That is Korean.
Yeah, so it's still in Korean. So to look at those buttons, I had to pull out Google Translate on the picture for it to interpret it for me. There's little things like that, that you don't necessarily see on. Granted, York, Carrier, and Trainer are all North American, but for chillers. But yeah, so there's just little things that I guess where I'm going with this is it's still new, and for it to be as popular as it is, they need to be a little more transparent on what we're working on. And yes, the techs do need to own up to what they're working on. But I think that's I guess in conclusion, it is a battle that, we really just need to actually compromise on, rather than just instantly blaming the other person. I guess I'm a victim of that right here and now.
Yeah. Well, and I think so. I think it really is more of a middle ground. I do think they could do a lot better with the quality control. I think it's one of the big things.
Screws. Screws on the plates. Yeah, those are good for two panel removals, and that's it. Even if you're not using a drill.
I agree. The panel system is horrendous. Why they still follow that same? They've been doing the same thing for 10 years.
All of them. Yeah. It's literally every brand that does it.
I know. I don't understand. It's cheap metal. Maybe they're cheaping out. That's what it feels like.
Some hinges and a clip, man.
But I think they could be a little more consolidated with how they present some of their install information, and make it a little more clear language. And I know it's definitely gotten a lot better. Reading manuals today versus reading the manuals they produced. I first started working on these 8 years ago. It's night and day difference. They're far better manuals now.
I'll have to take your word on that.
Yeah, no, they are. But they could do better. They could really. I think that's what it comes down to. It's just you really got to be able to interpret, which goes back to your point of the terminology thing. Like if in each one of them speaks their own language.
Yeah, if you don't know what a ref net is and everybody's terminology, you're like, what is that? It's a Y, dude. Oh, okay. Yeah. Okay, why didn't you just say that? It looks like a Y. It acts like a Y. We're going to call it something different.
Yeah, well, but why does York call theirs a PRV?
I was going to get to that right next. So, it's the same thing. And if someone doesn't explain that to you and they're talking about it, over the phone, you're like, man, I'm going to be honest, I don't know what that is.
It's like Apple to Android. Apple's names all their own thing, their special thing, and it can't sound like anything Android does. So it's in the same realm of things, right? Everybody's got to put their trademark on it. Yeah. Well, as a whole, I don't see this going away for a long time.
Oh, no.
And this is something that I think the schools could start doing a lot better with. I think that contractors really need to start putting a lot more effort than they have. And that's something else, because we're seeing these things go in. We're seeing them put in all the time.
We put them in.
We put them in. So
we're our own offenders here.
We are the ones, that just. I know that while some may have the experience of removing some of these because of the excessive problems. I would venture to say, and this may be a hot take, but I'd venture to say that almost all of those systems that are having to be ripped out probably had some significant install issues to begin with, or grid issues. So that's one of the Achilles heels of this system. I just had to fix this system the other day because it blew up the noise filter board, and we have terrible power in Austin. But on the vice versa to that, if you put in a phase monitoring system,
And that's what the local rep said here too. He's like, "Hey, how do y'all feel about phase monitors?
Yeah.
We love them.
Yeah.
We love them. They're great."
Between the mini splits and the VRFs, they do a great job. They can really do a lot to protect the system. So I'm all for it. So I think there's things we can do. There's a lot of things we can do that it's going to come down to educating and being willing to be open to learning something that is vastly outside of your current realm of what you know to do.
And I'll say this is when you get into your first VRV, VRF, variable call or whatever, spend the time to learn it because it will not be your last call. Right. Just because you hadn't seen one ever and you've been doing this for 20 years, unless you're, the hottest shit ever at your company, you're going to see another one. Yeah. So it's inevitable, and so you might as well spend the time to put some research into it. And I'm not nearly as intimidated by them as I used to be when I broke them all the time.
Right. And they are different than any other regular variable speed system. They really are, because we've got variable speed RTUs. Daikin's got them, Aeon's got them, everybody's got them to some degree. We've got variable speed split systems. Chillers have been variable speed for a long time. So we've got a lot of variable speed systems, but they do not carry the intricacy that VRF does.
Well, right, because variable for variable refrigerant doesn't necessarily mean just variable refrigerant. It's variable speed compressor, variable speed condenser fans, variable speed indoor fan motor, variable, you've got valves opening and closing in different variations, and then obviously you've got variations of refrigerant in different portions of the system. That's not necessarily the same as it would be in a typical refrigeration cycle.
Right. Yeah.
I'm sure I'm missing some variables in there somewhere.
I mean, it's gonna be a fun world, and I mean fun in every aspect, from the positive to the negative. I mean, I don't know. I'm a nerd at the end of the day, so to some degree, I find the technology fascinating. It appeals to me, but I'm also a gearhead at the same time, and the gearhead in me wants to chunk it off the building and just, why does this exist? So I feel the tornness, but overall the nerd kind of, it does take over a little more than the gearhead most of the time.
Yeah, trying to understand the algorithm, I think, is what really drives it for me. Is, oh, this is happening because of this. This is happening because of this. Oh, well, just because one unit's calling for cooling doesn't mean the rest of the system is performing in a call for cooling situation. And so understanding how all of that works together to provide this one space cooling is what really drives it for me.
Mm-hmm. What I'm curious of, and we've just started to get into the water source. We've just started to get into the water source VRFs, and so I'm very curious as to how that type of technology flows and ends up working out, because it seems like it's been a fairly mixed experience.
If it replaces water source heat pumps, I am all for it.
I agree with that. So I guess, well, I say I agree with that. I mean, I don't know, do I? Water source heat pumps, yeah, they're horrible to work on, but
damn near bulletproof sometimes, though.
Right, and think about how challenging it can be just to get an air-cooled VRF functioning. Then you're going to turn around and stick it in a mechanical closet and pump water through it. Now think about all the issues and how sensitive a water source can be with flow issues. Now compare that to a VRF system, and it starts having flow issues.
Yeah, I guess that comes down to, I think at that point it comes down to not just the contractor, right? Is you have to have a facilities team that has an understanding of what's going on. Because at that point you're not just replacing split systems. At that point you're adding that hydronic loop to it, and that comes with its own headaches. And you're right. I don't think I would recommend a water source system unless there was very clear reasons to.
Yeah, well, especially not open loop in particular.
Oh yeah.
And the one in particular that we do have, it is a closed loop, but it goes through heat exchangers. So the actual tower is open loop.
Okay, but the actual condensers or heat pumps are isolated from the outside. Okay.
So, for me, that'd have to be a given. And even with that system, because it's an older piping system, we still have a lot of issues with it.
I was unaware we even had this.
Yeah. No, we do. It's in San Antonio, so it's different profile from yours, but yeah. So it's, I don't know. I'm curious to see just how far it goes, and just what's the breakover point for some of this technology.
I mean, I see the advantage to that though. Is if you're pulling out a chiller system and you're putting in this water-cooled VRF system.
You've already got the towers.
You've already got the towers, and you've got the mechanical room to shove everything in there. So I see the advantage, and that would pretty much be where I would only recommend it in that situation. But if you've got roof space or yard space, I'm recommending air-cooled, despite the fact that I work in 110 degrees outside.
Well, one great thing about it, the efficiency aspect, we have a lot better control of the water.
This is true.
We're not going to suffer from the same ambient conditions we would have. At the same time, look at the retrofits that we've got going. Like what we doing downtown, where we're pulling entire coils out of an old York split, and we're having custom coils built and putting that into an outside air system. And that's becoming a very popular option. We get a lot of requests, a lot of questions about that. And it works. It works great. It takes a little tuning. Each one, even though we've got two right now, we've done side by side, they're different sizes. And one actually ended up needing a little bit slightly different time tuning on the staging aspect of it than the other one did. So that was interesting to kind of see the comparison between them.
Yeah, and you're not doing that if you don't understand how the SIL system works. And that goes back to what we talked about earlier. But I do think it's going to compound itself, like you said. What happens when you get a whole fan wall set up this way?
I hadn't even thought about that. Yeah. Imagine that in a self-contained.
Yeah, exactly. You pull out a vane axial fan system and you put in a fan wall with that. Wow. Yeah, that's a whole other ballgame.
And genuinely you could, because you could do, even if it was in 4 or 6 or 8 coil sections, like you could design a system to do that. They would just all have to run together.
It's weird you said the self-contained one. I mean but the self-contained one though, that would essentially just be your water-cooled system, just all shoved in next to each other.
Yeah, to some degree, yes.
Wow, that would be cool though.
Even on the fan wall, let's say with a vane axial system. So for those who don't know, there's some buildings where you have one, maybe 2 very large air handlers that take up,
You walk into the building is built with these in mind as an architectural structure.
Yeah, they are part of the concrete pour. And so the coil wall may be 20 foot wide by 10 foot tall. And so you've got 1 or 2 very large fans in there, and we call them vane axial fans. Most of the time, a regular squirrel isn't going to be able to handle that kind of volume.
You're talking 100 and 150 horsepower motors sometimes.
Yeah, exactly. So yeah, with that, you really could though. You could take and just parcel up. It wouldn't be one large continuous coil. You'd parcel up each little section of that coil, run that to a bank of outdoor units, tie them all together to a central system, and the reality is they could still unload.
Yep.
Even if you had 6 or 8 banks, they could still unload to a lower capacity than the chill water system that was connected to it. And as long as you've got everything piped correctly and you've got it all charged correctly and you're running them simultaneously,
Yeah, and then you've programmed it correctly. That's the other part of it.
they'll do their thing. Because we're doing that now. We've got systems and air handlers on a smaller scale.
Right.
It's 2 coils side by side, but we know that we did everything by the book. And it took a lot of time. It's not easy to set up, and we had to do a lot of vetting. But
And a whole
that
repipe.
thing just it kicks it. I mean, it's great, and it's extremely efficient. Yeah, it's interesting. It's gonna be, yeah.
I don't know. I mean, I'm not, fancy up to date car mechanics, but I mean, are these similar systems placed in automotive ACs?
Well, what I see in automotive is they're going to variable speed compressors, but not the kind of variable speed we think, or maybe.
I mean, I know we've got variable speed compressors and variable speed motors, obviously, and because the way my Chevy works is that I can set a temperature and everything's going to modulate itself the way it wants to,
Right.
to hit that set point. But I don't know to the in depth of how this works inside an automotive.
They can do that based off of just the internal dampers, so they can control cabin temp just based off of that alone.
That's true.
But they have come out with compressors, and I say variable speed. I don't think they're actually variable speed. Is they have the ability to unload the cylinders in a specific way, and so it's a different technology altogether.
Okay. Yeah, I'm not automotive in terms of car ACs.
I don't keep up with it as much as I used to. I used to work on them all the time.
Well, in the last car I worked on, I ripped it out, so.
Well, there's that.
It was a convertible, and I'm bald, so it worked out great. There was no sunburn involved.
Oh man. All right. Well, that's a good synopsis. Ultimately comes down to VRF. They're here. They're going to be here for a long time. Take the time to learn them now while you can. The longer you wait, the more they're going to take over, and the more issues are going to start to happen, and the further behind you're going to become ultimately in this industry. And it's very interesting. I think it is possible that the VRF techs, to some degree, start to really compete with what used to be just the chiller techs. In the old days, if you will. They were always the top end of everything, and the chillers aren't going away. That's the other side of this. While there may be fewer of them getting installed on smaller applications like they used to, they're not going away entirely because VRF cannot compete at this scale.
Right, you can't have a VRF plant, to run multiple large buildings.
Yeah.
You can't run facilities. I mean, and I think the story I heard is, Jerry World up in Dallas. They've got a chiller plant that runs 1.5 miles away from where the actual stadium's at. VRF can't do that. You can't run chilled water pipes that far away.
No.
And I'm sure, and I know there's other larger chiller plants, but that's the one that I know of.
Even still, the tonnage behind that. They're not going to get to that kind of tonnage. At least not that I expect.
Well, it's like what boats, right? Large cruise ships and stuff. They've got chillers.
Right.
You're not, again, unless you're using the water cooled VRF ones. But I mean, you're not turning off a cruise ship ever. Once that thing starts up and gets out on the water, that thing runs. So bam, chillers are perfect situation for that. You get that centrifugal running. Okay, don't turn it off ever.
Yeah, well, yeah, you get those parameters dialed in between the water and the chill water side. Those things are just cruise.
Mm-hmm.
So chillers aren't going to go away, and so that side of the industry and that niche that it is still going to be extremely sought after. But I question. I'm not saying that it's true, but I question. Are VRF technicians, like good ones, are they going to at some point rival in importance in this industry as how we view chiller technicians? Because you see this in a lot of conversations with a lot of company owners or even management and such, and just even just taking and pushing certain technicians into, well, that's our VRF guy, that's our VRF guy. Where for a long time, you had your boiler guys, you had your chiller guys. Now you've got your boiler guys, you've got your chiller guys, and you've got your VRF guys.
But at the same time, that's from a contractor's perspective, right? That's who they're sending out there. But when it comes to a customer perspective, there's very often. I mean, we did see it this week. They were able to, hey, this is our VRF guy. The customer knew the VRF guy. Like that is a very real thing that happened. Whereas when you're a chiller guy, hey man, Kirk's coming over. Like everybody know who he works for. It's not just like, oh hey, APS is coming over. It's like, hey, Kirk's coming over. Something like that.
That's our chiller guy.
Right. I mean that they understand that, and a lot of times too is when that chiller guy switches companies, that customer switches contracts. And I would not be surprised to see that happen in the VRF world because of that.
Well, then it has. This happened with me. I can speak from experience. I've had customers who were VRF customers who did follow me for those very same reasons. So it's here.
Yeah, so I would not be surprised to see VRFs put up there with the chiller techs. Now, granted, I think the difference between a chiller tech and a VRF tech comes down to the emergency of the call, because when your chiller goes down, your entire building's down. Like and sometimes it's a courthouse, and you're like, what the heck's happening here? And I'm in over my head and what have you. But if one bank of VRFs go down, there is some forgiveness that can be had depending on which section of the building went down.
Yeah, absolutely.
So.
Yeah, well, then that goes back. That's a whole other conversation behind, lack of redundancy in chill water systems, which goes into people cutting their budgets too short. And anyway,
that's a whole other podcast.
Oh yeah,
and that one would be very difficult to.
It'd be a lot of ranting.
Yeah, that would just. I don't know how professional I could be at that one.
Okay. All right. Well, we're going to call that. Appreciate everybody. Hope you enjoyed the chat. If you agree, throw a comment. Let us know. If you don't agree, that's fine too. I'm curious to hear your thoughts. Even if you think this technology is it's on the edge of death, that's okay. You know your specific region better than we do. But speaking from what we see in the areas we work, and I consult nationally, and to some scale globally through HVAC Time as a brand, and a lot of the consultations I work through are VRF related, and just the fact that this isn't slowing down, not that I can see, not in any form of the way. But people do ask the questions when they get into the extreme scenarios. Can we even salvage this system? Most of the time the answer is yes, but you're going to have to make a major investment, and but it will be a lesser investment than purchasing a brand new system at that, as long as it's not too extreme. I mean, it could be. Either way, MTT, take care of your family, take care of your spouse, spend the time with them. We'll see you around.